Hi everyone, welcome to your first physics lesson. We're going to start off real slow and real simple with a lot of stuff you probably already know. So that should be good. We're all going to figure it out as we go along. So the first thing I want you guys to do every single class is take a look at this practice problem and solve it in your notebooks or wherever you're taking your notes. You guys don't necessarily need to have notebooks right now, but I think it's a good idea. If we ever transition back to in-person class, I'll definitely be checking your notebooks. So I think paper notes are a good way to take notes, even though everything's online. So try this problem. I'll be right back. The answer is choice 2, 100 meters. It's a square field. When it runs 5 meters per second, it takes her 8 seconds. So that's 2 seconds per side. If she runs 5 meters per second for 2 seconds, each side is 10 meters long, which is choice 3. But that's not what the question asks you. The question asks you for the area of the field. And you guys probably already know the area of a field is usually a square. A square field is just the side length squared. So 10 meters times 10 meters, 100 meters squared. Choice 2. But there's another way you could have solved this problem. 40 meters, 10 meters, 100 meters squared, 200 meters per second. An area must be in meters squared. And we're going to start off real quick with units. Very, very straightforward. Speaking, listening, lesson. Okay. But first, a little bit of what is physics. So if you guys were able to solve that problem, or at least understand what it meant to say 5 meters per second, you're already good on the first step, the first idea in physics. 5 meters per second is a speed. You guys might be more familiar with the speed of something like a car or a train, which might be something like 60 miles per hour, which is a good starting point. We'll start with this example. Speed is a mathematical model to predict what will happen. If I drive my car 60 miles an hour, then I can estimate it'll take me an hour to go 60 miles. If I'm going someplace 120 miles away, it'll take me about 2 hours. That's not necessarily true. There's obviously things like traffic and roundabout ways and getting lost that could affect this trip time. But if we know this speed, it can be used with our knowledge of math and our knowledge of the universe to predict what will happen when we do something, like say we drive to Boston from New York. That's what physics is. It's making a mathematical model using your knowledge of math and logic, comparing it with the universe, comparing it to how long it took me to drive to Philadelphia or something, and predicting how long it'll take me to drive to Boston. A mathematical model. This one's pretty straightforward, 60 miles an hour. We'll come back to this. You guys all know 60 miles an hour is 1 mile a minute. But we're not going to use 60 miles an hour very often in this class. We're going to use base SI units. I could just listen for you, but I'm not going to do that right now. We're going to talk about stuff. It's really, really important to measure everything in physics really, really carefully. If you don't measure properly, you can't make a mathematical model because your information is not accurate and you can't really do anything. So we have to be very careful with all our measurements. Ideally, if all your measurements are perfect, you can, for now, make a mathematical model for anything. Like we know that, oh, I drive my car 60 miles an hour is a model that works sometimes for predicting some trip durations, but it doesn't always work. In theory, for now, if we could measure everything perfectly and we knew all physics in the whole entire world, could we model everything and anything? This is not really physics. This is kind of a philosophical question. Is it possible to model everything completely perfectly? For instance, um, if I have like some fake AirPods that I got for like $5 from a guy on the street, you can like take them apart, you can listen to them, you can use them, and you can measure things about them to realize that they're not real and that I got ripped off. But if everything about them were exactly the same, there'd be no way to tell that they were any different from the real thing. That was a silly example, but we're going to look at some examples that are kind of related. Let me try to explain it another way. So, this is a philosophical idea called the Ship of Theseus. We're going to watch it really fast.
So imagine Theseus has a ship. It's made up of some planks, a mast, and some sails. Along the course of his journey, one of the planks is rotten, and Theseus has to replace it. Is it still the same ship? I think most people would say a single plank being replaced. It's the same ship. But what if we replace another plank? Or some more planks? At what point does this ship become no longer the same ship? When the last plank has been replaced? If you had the intuition that this is still the same ship, what would happen if someone took all of those planks, the mast, and the sails from that old ship and made another ship? Which one of these ships is now Theseus's ship? Being a good skeptic, I'm not going to solve this problem for you. I'll leave that up to you dogmatists that want to believe in concepts like identity.
Okay, so that was a tough question, but the idea I'm trying to get across is if you could make everything exactly the same, down to like the tiniest little atom or tiniest little piece, would something be the same? That's not exactly what Theseus, or not Theseus, the philosopher was trying to convey when he proposed this idea. But what if we could measure everything perfectly? If I measure the speed of a bullet and the mass of the bullet and the force it'll apply when it hits the wall, could I predict exactly the hole it'll make in the wall every single time, no matter what? Sure, there's air resistance. Sure, there's um, slight discrepancies in how each bullet is made. This is a bad example. Sure, every wall could have like pre-existing cracks. But if I could measure all those things precisely, is it possible to predict what everything will do in the entire universe? If I had a big enough supercomputer and smart enough physicists and enough data, could I know what everything, every star, every planet, every comet, an asteroid, every person will do for the rest of time? That's a tough question in physics, but if you believe that physical laws are true, as far as we know, and or even if they could be true, that we could know these things, then yeah, we could predict a lot of these things. We're obviously going to predict much simpler things. So I'll give you guys another example. Don't worry too much about that whole philosophical ideal thing. That's just something I like to talk about sometimes, but we're going to focus on some more physics after some more philosophy. So we're going to skip over to this. Back to speed. Speed is great for predicting how long it takes me to drive to school. And I'm taking like a lot of time to get to school right now, and it's pretty tough for me. I'm very sad. I could just work from home, and that would save me a lot of time. So I'm thinking, oh man, I'm wasting so much time driving to school. Sure, I can predict how much time it takes me, but it's a lot of time. I wish I could just teleport. I wish I could just like jump in to this little machine in my house, and then somehow I could teleport out into school. That would be really nice. That would save me a lot of time. I wouldn't need to speed or any calculations at all. I could just instantly travel the distance from my home to the school. That would be great. If this exists in like Star Trek or some TV shows, sci-fi shows, but in Star Trek, they have like you probably never watched Star Trek, but they try to be very like scientific with all their science fiction, and they say, oh, there's a scientific explanation for everything in the show. In Star Trek, when you use a teleporter or a transporter or whatever, the machine you step into breaks up all your atoms and transports them through space super fast and reassembles those atoms into your body exactly the same way. And your memories remain, your personality stays the same. Somehow, when they make every atom put back in exactly the same spot, they make a person that's exactly like you. But the question is it you? Would you use a transporter like in Star Trek if you could? If it would save you a lot of time? If you could travel to like the moon and the planets and different galaxies, would you guys use it if you knew it'll break down your body into individual pieces, transport them, and reassemble them perfectly? Tell me what you guys think. Tough question. And it gets even more complicated if you think about it. What if the atoms that are broken apart are not the same atoms? They're still atoms, exactly the same kind of atoms, and they're still reassembled the same way. But if they weren't the same atoms that made you up originally, would you be the same person on the other side? Clearly, if the atoms are not reassembled at all, you'd just be dead. If a machine broke up all your atoms, you would not really survive. So that's not ideal. But what if, instead of reassembling atoms into a perfect copy of you once, they just do it twice? What if they make two copies? They measure every position of every atom and everything else about you, like your weight, your eye color, your hair color, like all your hairs, the texture of your skin, every single thing, and they make two exact perfect copies with all your memories, your entire personality, everything about you the same. Are they both you? That seems like a tough question. Here's a little comic that I saw recently that tries to convey the same idea. The fourth panel is kind of like not appropriate, so we're just gonna pretend we're not looking at that. I'll just cover it with my hand. Okay, ready, set. I'm covering it right now. Hopefully it's working. So check out this comic. Think about it. Is it the same as you if it's a copy, an exact perfect copy, and you still have all your memories? I don't know. Okay. So today in class we're going to discuss these ideas. Is it possible to make an exact copy of something and predict what will happen? No, sorry. A few ideas to discuss in class today. Would you use a teleporter? Yes or no? Why? Are you the same person if it reassembles the atoms after teleporting them? And what if they're not the same atoms? What if they're different atoms? In both cases, are you the same person? And obviously, a whole person is a very, very complex system. We're going to keep it much, much simpler. Like, let's just say a car going 60 miles an hour. Yeah, sure. If we had a perfect, like, system, like imagine a perfectly straight road with no traffic, just open in the desert, and we have a magic car that never runs out of gas and always drives exactly 60 miles an hour, and a magic driver that never turns and just drives straight on and on forever, then we could have a perfect model. Yeah, he'll go 60 miles in 1 hour, 120 miles in 2 hours, 180 miles in 3 hours, etc., etc., etc. Well, to what extent can a model like this be applied to the real world? Like if I'm trying to predict where a real car will go after I drive it off a cliff, how accurate will I be? That's a tough question because it depends on knowing the physics of a lot of different things, like the car, the cliff, the air, gravity, all this stuff. So, how accurate do you guys think it can be? How useful is physics if it's not accurate? A very important question to discuss in groups. We're going to try really hard. I'm going to figure out breakout rooms. It's going to be fine. We'll get more into measurements later. But the main idea for today's lesson, this is what physics is, designing a model, and why it's so important to have good measurements.